Good afternoon, everyone. Let me start my discussion, and I'm gonna go over quiz 31 and a little bit of 32. Quiz 32 is more like of general mathematics, so I'm just gonna go over quiz 31 and a few questions that I thought were interesting in quiz 32. Okay, so in quiz 31, I just chose questions 11, 8, 6, and 5. But of course, if someone joins and he or she wants me to go over some specific question, I'm happy to do that. Okay, so in question 11, we have that function and we have to sketch the graph and then compute that integral. So like we know this function looks like this. That is how an absolute function looks like. And at this point, so you can see that when x is 0, right, then y is the absolute value of -4, which is just +4. So I expect this point to be 4. Specifically, this point is 0, 4. And this point here is 4, 0. And I'm interested in computing the integral from 0 to 10. So from this point to some point 10. So maybe some point 10 here. So I can say this is point 10, 0, okay? And clearly you can see that when x is 10, when I put 10 here, then y is equal to the absolute value of 6. So when x is 10, then this point here is actually 6, something like that. So computing the integral from 0 to 10 of this function, so it is from 0 to 10 of this graph here. So this is the same as computing the area under this graph and area under this graph. It has two parts, so I have the first area and I have the second area. So clearly the integral from 0 to 10 of absolute value of x minus 4 dx is the same as the total area under this graph, which is area 1 plus area 2. So I can compute area 1. Area 1 is a triangle. It has a base of 4 and a height of 4. So area 1 is a half base height, which is a half times 4 times 4. And when this cancels, this is just 8. Area 2 is the same. It is a triangle, a half base height. This is a half, and base is 10 minus 4, which is 6. And height is also 6. So this is 3, and this is 18. So therefore, the total area, which is the integral from 0 to 10 of this function, is actually area 1, which is 8, plus area 2, which is 18. And this is 26. Okay. Question 8. Question 8, we are given a graph of a certain function and we want to compute the integral from -1 to 10. So from -1 to 10, still, this is the area under this graph from values x equal to -1 and x equal to 10. So if I look for those values on my graph, then -1, so we are interested in moving from this point here and to 10, and 10 is right there. Okay, so we are interested in the area under the whole of this graph. So we are interested in that area. Now, I can divide up this area into different shapes. So I can create that as one. If you don't want, you can create this as a trapezium, but it doesn't matter. So I can create a triangle and a square, and then I have this trapezium here. Okay. So this is, let me call this area 1, this is area 2, and this is area 3. And if I calculate area 1, once again, it's a triangle, so that is a half times base times height. And this is 1/2, then times the base. The base is from -1 to 1, so this is 1 plus 1, which is 2. And the height is also 2. So this is equal to area 2 is a square, which is side times side, or side squared. And this is the same as, once again, the side is 2, and the other side is also 2. So this is equal to 4. Area 3, like I said, it's a trapezium. Now, I'm choosing it to be a trapezium. If you really think you can't remember the formula for the area of a trapezium, I could divide this like this, so that I have a rectangle and a triangle. We should be ending up with the same answer. So when I use this as a trapezium, the area of a trapezium is the same as half h into a plus b, and h is the height of this trapezium, which is this guy here. Then a is the shortest side of the trapezium, and b is the longest side of the trapezium. So this is a half h, and h is all the way from 3 to 10. So from 3 to 10, that is 7. So times 7 into a is this side here, which is 2. Then plus b is the longest side, which is from here up to 9. Hope you can see that. So this is 9. Okay, so this is 1/2 times 7 into 11, and this is 77 over 2. So our integral from -1 to 10 of this function f of x dx is equal to the total area under this graph, and the total area is A1 plus A2 plus A3, and this is the same as 2 plus 4 plus 77 over 2, and when we add up this, we just get 89 over 2. I hope that's fine. Question 6. We are given these integrals, and we want to find the integral from 5 to 1. Okay, so according to the integrals I'm given 1, I can find integral from 0 to 5 of fx dx, and integral from 0 to 5, I can say it is the same as integral from 0 to 4, then plus integral from 4 to 5. Okay. But integral from 0 to 5, this guy on the left-hand side, I can also write it as integral from 0 to 1, then plus integral from 1 to 5. Okay, and this is the same as integral from 0 to 4 f of x dx, then plus integral from 4 to 5 f of x dx. Okay, so maybe let me carry up this thing. So 0 to 4 is right here. So we shall substitute it right there. 4 to 5 is right there in green. 4 to 5 is right there. 0 to 1 is right there in yellow. So we shall substitute it there. And you can see we have everything apart from integral of 1 to 5. Okay, so integral from 0 to 1 is 3. Is 3 plus integral from 1 to 5 f of x dx. Integral from 0 to 4 is 4. Integral from 4 to 5 is 3. And you can see that I'll have integral from 1 to 5 f of x dx. This is the same as 7, which is 7 minus 3. And this is equal to 4. But remember, this is integral from 1 to 5. The question is asking for integral from 5 to 1. So therefore, I have integral from 5 to 1 of f of x. Remember, it is the same as negative integral from 1 to 5 f of x dx. So when I switch up the limits, I put a negative behind, and this is negative, this is negative 4. Okay. Again, question 5, it's almost the same thing. I want to move this a little bit down here. So question 5 is almost the same thing. We are interested in integral from 3 to 7, and so I can have integral from 1 to 7 of f of x dx. This is the integral from 1 to 6 f of x dx, then plus integral from 6 to 7 of f of x dx, right? Now, this is integral from 1 to 6 f of x dx plus, now this 6 to 7, I can write it as integral from 6 to 3 f of x dx, then plus integral from 3 to 7 f of x dx. But remember, this guy here is 6 to 3. Usually when we are integrating, we have to move from the lower limit to the upper limit. So that's why if I have upper to lower, I switch to lower to upper, but I put a negative sign. This should be here. Okay. Okay, so I can then write this as integral from 1 to 6 f of x dx plus, now this guy I can put a negative and switch the limits, so 3 to 6 f of x dx, then plus integral from 3 to 7 f of x f of x dx. And I have everything, so I can just substitute. So remember, this is integral from 1 to 7 f of x dx. So once again, I have everything. So in red, 1 to 7 is right there. In green, 1 to 6 is right there. Then 3 to 6 is right there. Maybe in another color. So 3 to 6 is right there. And 7 to 3 is right there. So you can say I have everything apart from I have everything apart from 7, 3, which I'm interested in. So when I substitute everything, the integral from 1 to 7 is 1. And this is equal to integral from 1 to 6. Integral from 1 to 7 is 7. Integral from 1 to 6 is 1. Then minus integral from 6 to 3, which is 6. Then plus the integral from 3 to 7 of f of x dx. When I bring everything the other side, I have 3 to 7 f of x dx. This is the same as 7 plus 5, and this is the same as 12. Okay. Okay, quiz 32, like I said, quiz 32 is just about some general mathematics. So I just chose a few questions, and first one is I chose question 11. So question 11, because it is composite functions. So I'm interested in finding f composite g, but evaluated at 2. So which means I have to first calculate f composite g of x, and this is f of g of x. Now, composite functions, what this means is that you go to the function f, which is this function here, and wherever there is x, you substitute that x with g of x. So if I'm to write this, actually it should be 4e to the power 3 then times g of x. So in the function f, wherever there is x, I'm substituting it with the g of x. I hope that is fine. Okay, so this is the same as 4e3 times, but what is g of x? G of x is 2 over 3 natural log of 5 5x, and therefore this 3 can cancel, and when that 3 cancels, we have 4e to the 2, then natural log of 5x. Now, from the rules of logarithms, these 2 can come on top there. So from the rules of logarithms, these 2 can come on top there, and we shall have 4e natural log of 5x then squared. Once again, like I have been saying, natural log squared of 5x and natural log of 5x squared, these are two different things. This one means that you're squaring the whole function, but this one means the square is just on top of 5x. Okay, but remember one other thing, remember that whenever I have exponential natural log of x, I just get x. Generally, natural log exponential natural log of a certain function. Let me use h of x. This just gives h of x, okay? So this guy here just gives 4 then times 5x squared. So e natural log, that one goes away and we just remain with that function there. And this is the same as 4 times 25 x squared, and this is 100 x squared, and that is my f naught of g of x. But the question is asking for f naught of g of 2. So I go in my composite function, wherever there is x, I just put a 2, and that is the same as 400. Okay, question 14. We want solve for x, and yeah, so we have an absolute function somewhere. So question 14, I want to solve this equation, and when I take 9 this side, I'll have a negative 2 absolute value of x minus 3, and this is the same as negative 7, right? I can divide by negative 2 both sides, and I'll have absolute value x minus 3 is equal to 7 over 2. Now, remember, whenever I have an absolute value of something is equal to some number, then this means that either this a is positive k or a is negative k. So whenever I have an absolute value, it means two cases, right? So this means that either x minus 3 is equal to positive 7 over 2, and if this is the case, then x is 7 over 2 plus 3, which is equal to 13 over 2, or x minus 3 is equal to the negative 7 over 2, and if this is the case, then this means that x is negative 7 over 2 plus 3, and this is minus 1/2, okay? And those are the two possible values of x that we get as a solution of this equation. Let me first go over question 15. So question 15, we just want to find a composite function value, but using a graph. So remember what this means. G naught of f at 6, this means G of f of 6, right? So what does this mean? This means that I first go to the graph, I determine what f of 6 is. So I determine what f of 6 is, and from the graph f of 6, this is the graph of f. This is the graph of f. So 6 is right there, right? So I move up until I hit the graph of f. So f of 6 is right there, which is 2. So from the graph, f of 6 is 2, right? And if f of 6 is 2, that means that I want to determine g of f of 6, which is g of 2. And so I come to the graph of G. So find the 2, move up until you hit this graph of G. So I move up and G of 2 is right there, which is equal to 5. So this is equal to 5. So therefore my G F6 is just the same as 5. That is easy. Okay, then question 29. I thought I should go over question 29 because it has something we've been talking about. And question 29 says that we need solve for x. Now, this is where we use one of the rules of logarithms. And remember, if you remember very well, we had, if I had logarithm of a to the x, no, a to the b is equal to x, then this means the base remains the base, the result becomes the power, and the power becomes the result, right? So whenever I have something like this, I can write it like this guy here. So this guy, compare it to this. So A is my 8, B is my 12, and X is my X minus 6. So I want to write it back in this form here, okay? So you can see that my A, I'll have logarithm. So this will be logarithm of A, which is 8, right? Then to the power B, which is 12, and this is the same as x minus a. Remember, I'm trying to find x. So this guy will be the same as, so this means that x is equal to logarithm of 8, then 12, then plus 6. And according to the multiple choice answers you had, your answer looked like that. Of course, this thing can be manipulated in so many other ways, and you can find so many answers from this guy, and whichever answer you get, as long as you're doing the correct thing, it should be correct. Okay. Okay. So unfortunately, I can't ask whether that's fine or not because yeah, I'm here alone. So I'm just gonna stop here. I think these quizzes are due tomorrow. So if you watch this, kindly make sure that you do your quizzes by tomorrow night, I think. And yeah, good luck in your test 3. Bye.